21-year-old girl shot up at the card shop, and all these men are just talking about war when closed. It's so stupid.
Let's see if I remember how to do this. There we go. So I'm just going to post this. Okay. Slowly getting there. Okay. All right, we'll go ahead and get started then. I'll just pass out some different things for you. Okay, so first thing is first, I just handed out the syllabus for this class. I'm guessing that's probably how most of your day has been with your other classes, if I'm not mistaken. So just some general things. I won't go into a lot of detail with them, just because it can all be found here. For those of you that are online, you can find it under the syllabus section on Canvas. But essentially, I'm AJ Zelinki. That's my name. You can call me Mr. Z if you'd like. That's what I go by over at Du Bois Central, where I teach throughout the day. This is Math 111. It'll be a Monday, Wednesday class, 5:30 to 6. It should be 6:45 instead of 6:15 there. So my apologies for that. For those of you online, you'll see live streams that I have here posted as the class happens in Du Bois. So feel free to tune in at any time. They are recorded, so everybody will be able to see what's going on there. Let's see, this course does use Pearson, and I think almost everybody in here got that to work, I think, when I was looking at it earlier. Were there any issues getting that set up? Okay. So all of the homeworks will be in that platform, which can be found right in Canvas. The grade breakdown homeworks, 10% altogether. We'll have some in-class assignments, which will be 25% altogether. 3 exams throughout the semester, each of them being 10% each. 2 projects, which will be 15%, and then a final exam at the very end for the remaining 20%. With the homeworks, you actually can submit them past the due dates. It's just a 10% penalty off if it's past the due date. But if you ever need to be absent from class or if something comes up, just feel free to send me a message. I can always work with you if stuff happens. And let's be honest, life does happen, especially this past week. Let's see. You can send me an email at any time. You can also send me an inbox message directly in Canvas. That tends to work pretty well. If you do need to make something up from being absent, I usually just ask that it's within a week, if we can help it. The only time that would probably vary would be if it was, say, the end of the semester, when I have due dates from the college specifically. Everything else is pretty much self-explanatory, I think. Something that tends to happen in the spring, as you have already seen, is that sometimes classes get canceled. So I apologize that happened to you for the first 2 days of this class. But if that happens, just expect to see things in Canvas that I'll post for you. For this section, I'm pretty much just going to follow the Du Bois School District. So if Du Bois cancels for the day, chances are I'm probably going to say a remote class of some kind, just to make life easy. If there are other times when the college cancels directly, then I'll make you aware of it in announcements too, because that's what happened on Wednesday last week. As far as Canvas goes, everything you need is in modules. As far as assignments, materials, that sort of thing. And as we go throughout the semester, I will post some different things in here. The very first module in here will be where you can find all of the class recordings. Any questions related to Canvas? Okay, so before coming today, I gave you the videos for chapter 3. Did anyone have any specific questions from that chapter? Is there anything that you weren't sure about or anything that you'd like me to clarify? Everything seem okay? Okay. If we ever come across something that you're not sure of, just feel free to speak up. I can always re-clarify things or approach it a different way if I need to. Okay, nothing in the chat either. So what we'll do then, we will go to chapter 2 tonight. For those of you who are here, normally I would just give you printouts of the slides myself, but that became impossible for chapter 3. So this first one is for chapter 3. So those go along with what the videos were about. That's the one we're going to start tonight, chapter 2.
Thank
Okay, I think this will work better this way. One last thing for the online section. So this won't apply to you guys here. But for those of you that are taking the online section of this course, when it comes time for exams, you will need to download the Respondus lockdown browser. So there's going to be some links in Canvas to do that, but you'll need to download the lockdown browser in order for any of the exams to work for you. First exam won't be for a little while, so you'll have some time to figure that out. Tentatively, I'm looking at first exam on Monday, February 16th. So about, what's that, 3 weeks from now? Something like that. Okay. And then for those of you here, any exams we do would be paper-based. And you'll just need to make sure that you have access to a calculator of some kind. I should mention, if you don't have a calculator that's not your cell phone calculator, just because I'm not allowed to let you use your cell phones, I do have extra calculators over in my classroom at DCC that I can bring over if I need to. Just let me know if you need me to get you one. I can always do that. All right, so chapter 2 is going to be dealing with problem-solving techniques. Particularly units is going to be the key. So understanding what the problem is, solving the problem out, explaining the solution or solutions that make sense in the context of that problem. 3 steps to solving any type of problem: understanding, solving, and then explaining the results. Up to this point in your math journeys, I'm willing to bet you've done the first 2 things a lot. Have you had to do much of number 3? kind of? Okay. If you don't mind me asking, what was the last math course you had before here? Just out of curiosity. Calculus? Algebra? Okay. Algebra? Okay.
It's been a while.
It's been a while. It's okay.
I would say it was calculus, and I had to take calculus,
Okay.
chemistry.
Okay. Nice. I will say, in a lot of the things that I teach over at DCC, number 3 tends to show up quite a bit in geometry, particularly with proofs. We won't have any type of formal proof writing in this class, but just being able to explain why a solution makes sense or why it doesn't make sense. So understanding the problem is always, what's the problem asking you to do? Diagrams are always very helpful. I know you were mentioning physics a little bit earlier. That's definitely useful for that. Thinking about what the solution could look like, trying to come up with some different paths to get there. And I should say there's more than one way to solve problems, typically. As long as you can get to the answer and show how you got there, I'm good with whatever way you want to use. So I'm not the teacher that will say, you have to do this using this method. Just as long as you can show me what you're doing and how you get there, I can work with that. For solving the problem, always obtain the needed information. Organized methods are a must. Double checking if you have the time is always good to do that. Big one, if you're working through a strategy of solving a problem and it's taking you a long time, or it's just not making a lot of sense, chances are there's another way of going about it. And then explaining your results. Does the result make sense is the key question. So an example of this, if we were solving a problem with, let's say, gas prices, what's a typical gas price that you see around here?
Kind of varies. I don't know.
Depends on what sheets you get to.
Yeah. Like somewhere around like $3 or so.
Yeah, like
Yeah.
between
Mhm. Maybe high 2s if you're lucky,
yeah.
low 3s more than likely.
318, I think, in Clearfield right now.
Yeah.
Okay. That seems about right.
Yeah.
Because I live out over at Treasure Lake,
Mhm.
and I think it was 314 when I left there this morning. So probably around there.
Yeah.
But if we're working through a problem and you get, say, 30 as an answer, does that make sense in that context? Probably not, right? What do you think the error would be if you got 30 instead of 3?
Extra 0.
Extra 0. So either not moving the decimal one place or multiplying something by 10 somewhere. Just little things like that. If you can pinpoint where uncertainty comes from in your work, That's often a good place to start when things go haywire. And then always write the solution in clear, concise sentences in the context. So in other words, we solve the problem out, you get 3. What units would you want if we were talking about gas prices? Dollars. So you wouldn't want to just write the number 3 without that dollar unit there. Any questions so far? Okay, working with units. And this is going to be the key for chapter 2. Units of a quantity describe what is being measured or counted. And we basically need to work through different ways of manipulating units. All units need to be like in order to do operations with them. You can do things with multiplication, division, exponents, but typically not addition or subtraction. It says, note, it's easier to multiply by the reciprocal than divide. When they say reciprocal, it's just the opposite. Make sure final answer has the units that you're looking for. When doing these kinds of problems, you're going to be tempted to drop the units and just work with the numbers. But if you write the units out, it's another way of checking to make sure what you're doing is working. So it might seem tedious, it might seem a little bit annoying at times, but it's a way to check yourself, is the idea. Just make sure I don't have any comments so far. Okay.
Doesn't look like anybody was viewing the live stream.
And I don't think so.
I was gonna say your viewer count at the top is 0, so.
Yeah. It's interesting with that. Sometimes there's people there, sometimes there isn't.
Okay.
It's kind of interesting. Because sometimes they show up live and sometimes they'll view it later in the week. It's kind of an interesting setup, to be honest. Okay, so then we have a table of keywords with the operations that go with them. If you see per anywhere in the problem, that means division. So an example would be miles per hour. So that means miles divided by hours. Of or hyphen, which a hyphen is just going to be a dash of some kind, means multiplication. So the example they give here is kilowatt hours. Kilowatts times hours. That would be one of the units in physics with electricity. If you see square there, that means raised to the second power, or a quantity multiplied by itself. Cube or cubic is raised to the third power, which would be object times itself again. So some examples that we can look at. Car gets 32 miles per gallon and we're going on a 550-mile trip. How many gallons of gas will we use? This will make sense here in a second, what I'm doing. Have any of you ever used paint before? I found it to be very effective for writing out problems. Rather than just write on the slide. Granted, my notes look like a 5-year-old did them when I use this, but it works. So car gets 32 miles per gallon going on a 550-mile trip. How would you go about setting that up?
Divided by 32.
Yep, 550. Divided by 32. There we go. I knew the touch screen would work. 550 divided by 32 to give us 17.18. 17.19. Okay. Units would be gallons. Now, in terms of the actual units up here, 550 units or meters, technically over 1, because anything divided by 1 is itself. And then the bottom, you have miles per gallon, right? Have you ever had to work with a fraction over a fraction? Not really. Okay. Just a little trick here if you ever have to deal with this. A over B over C over D. Is equal to the extremes, so the topmost and the bottommost together on top. So A times D over the middle two multiplied together on the bottom, B times C. So if you're wondering why miles divided by miles per gallon goes to gallons, the top M and the G down here have to go together on top, right? Over one and the other M, right? But if you have M on both the top and the bottom, they cancel. You're left with gallons over 1 or gallons. So I'm just showing you the mechanics behind the units here. Any questions about that? Okay, if you drive at an average speed of 65 miles per hour on your trip, how many hours will it take? So we need to go 550 miles. And we're dividing it by 65 miles per hour. 550 over 65.
Is it 8.46?
8.46. The remaining units would be,
Did you want the rest of it?
you can keep going if you want.
Okay, it's 8.46, 15, 38, 46.
Okay. And then the units after that would be hours, which is what we want. If we drive at 65 miles an hour for 3.5 hours, how far will we travel? So think 65.
You times it with 65 times 3.5.
Yep. 65 times the 3.5, which will end up with
227.5.
227.5 units are miles. All right. Any questions on any of those examples? Okay. At your seats, let's have you try examples 1 and 2 here. Let's see what you come up with. Okay, answer for number one, anybody?
180,000
180,000. Good.
dollars.
Dollars. And then the second one,
Wow.
12 bins. Yep. Good. So we should be good to go there. Any questions? Okay. Generalizing this goes to conversion factors. So it's a statement of equality to convert between different units that are equal to the same measure. So the common one, 12 inches and 1 foot, you can write it as either 12 inches divided by 1 foot or 1 foot divided by 12 inches. The way in which you write this will be determined on the units that you're starting with and the units that you want to get to. Some problems might use multiples of these in order to get to the final units that you want. Anytime you're converting them, you have to have the same exponents in place. So in other words, don't try to do things with inches and then inches squared, or say feet cubed and feet squared. When they're different exponents like that, they're different quantities altogether. Fun fact, squared is an area quantity. What would cube be?
It's no volume quantity.
It's a volume quantity. Yep. So the exponent is telling you information about what the units are in terms of dimensions. So even though missing an exponent may not look like much, it's a completely different measurement, is the idea. If you are raising something to an exponent, it applies to both the unit and the number as well. So in other words, if you were going to go to square inches, you would have to raise the exponent on not only the inches, but the 12 as well. So some common conversion factors are there. So 1 foot, 12 inches, 1 yard, 3 feet. 1 mile is 5,280 feet. 16 ounces to a pound, 2,000 pounds to a ton. And a lot of the volume ones are used in cooking applications. So 3 teaspoons to a tablespoon, 2 tablespoons to an ounce, 8 ounces to a cup, 16 ounces to a pint, 2 pints for a quart, 4 quarts to a gallon. This is based on the imperial system, which we as the United States use, and I think one other country uses it. What does the rest of the world use, though? Metric. So you're probably going to see some metric ones coming pretty soon. But looking at the examples, if Amy is 5 feet tall, how tall is she in inches? What do you think?
Maybe 60.
Yep. 60 inches. If you've been studying for 3.5 hours, how many seconds were you studying? While you're doing that, I will write this out using the conversion factors. So 3.5 hours. What's a smaller unit of time from hours? Minutes. How many minutes in an hour? 60. If we want hours to go away, where should I put hours in this fraction? Fifty-fifty shot. Yep, you'll want it below here. So if you want hours to go away, whatever unit needs to go away needs to be in the opposite place. So 1 hour ,60 minutes must go on top then. Which allows hours to go away. We want this in seconds. So we need another conversion, which will get us to what?
60 seconds over 1 minute.
60 seconds. Yep, over 1 minute. Minutes go away then, because it starts on top there, then goes on the bottom to cancel. And then multiply straight across on both the top and the bottom.
I got 12,600.
12,600. Yep. Makes sense to me. But again, crossing the units out like that allows you to follow along what's happening with them. So next one for 3, you want to carpet a room that measures 12 feet by 15 feet. What is the size of the room in square feet? What would you have to do with those numbers? better yet, square feet can be rewritten as what?
Feet to the second power.
Feet to the second power. So really, the desired unit is that. From your days in algebra, how do you get to squared there if you have feet and feet?
Multiply your two numbers.
You'll have to multiply these together here. Just because when you multiply things with the same base, you add the exponents. So 12 times 15. 180. So that's the size of the room in square feet. The unfortunate thing is that carpet is usually sold by the square yard. How many square yards of carpet will we need for this room?
60 square yards.
60 square yards? How'd you get there?
You just take yard is 3 feet. You take 180 feet, you divide by 3.
Okay. So I like the idea. So 180 square feet there. And you know that there's 3 feet in a yard? That would give us 60 when we do that. But what would happen with the units when we cancel them out? In this case,
You still be in front of yards.
yep. So you'd have a yards on top, but then would both feet cancel out?
No.
Nope. One of them could, because this is really to the first, right? So if we get rid of one, that means this would go to 1, right? So really, our units here are going to be 60 yards times feet. We want square yards, right? So what could we multiply this by here? That would allow the feet to go away and for us to get another yard. Or how could you get the feet to go away? Where would it have to go? On the bottom. So if feet go there, that means yards have to go to the top. 1 yard, 3 feet. Feet cancels. But yard times yard would be
Yard squared.
yard squared. And then what number would we get? 20. So you were on the right idea. It was just,
I needed to follow through.
yeah. Or the other thing we could have done here, instead of doing this conversion once here, we could have squared everything. So like 1 squared yard squared over 3 squared feet squared. And then that would allow feet squared to go away directly.
What I did was,
Mhm.
I turned feet into yards. So I put 4 feet times, 4 feet times, or 4 yards times 5 yards.
Mhm.
20 square.
You could have done that too. But yeah, multiple ways of getting to the same answer, right? So any other questions so far? Okay, another common place this shows up would be currency exchange rates. The only thing with these is that these rates constantly change depending on the market. Have any of you in here traveled abroad, like out of the US? Okay. I did about 2 or 3 years ago now. I actually went to Iceland, and they have their own currency over there. The other place I went to was France, and they use the euro over there. So some common ones are up here. So any European country pretty much is the euro, so France would fall under that. Great Britain is the exception. They have their own. If you go to Canada, they have their own currency. China has theirs, Japan has theirs, Mexico has theirs, Australia has theirs. But these rates here change almost instantaneously on market conditions. But this is useful when you have questions like this. You're buying a leather coat in Italy for 275 euros. How much would this be in US dollars? Is the question. Let's see if you get the correct number for this. If anyone has a number, just let me know.
Is it $317.19?
That matches what I got. So even though cash register in Italy says 275, it's going to come out of your account as if it's 317 here. Or say we buy a pint of beer for $5.50. How much would that be in Great Britain pounds?
$7.42.
You're close.
Do pounds have a smaller denomination? Because they don't have cents.
Yeah, they do.
Okay,
Yeah, they call them, I think they call them pence over there.
okay.
Yeah. But if we're starting with dollars, in order to get rid of them, the conversion would have to be what unit over what unit.
It has to be like, it would be 550 and then over the dollar, like, through the dollar would be like that. To cancel it out.
Yeah. Yep, so pounds would have to be on top and then dollars on the bottom. What do you think?
1.08.
4.08? That matches mine. So 4 pounds and 8 pence, I believe, is how they would say that over in Great Britain. Number 3 is an interesting one. If you ever try to get gas outside of the US, gas prices are not reported in gallons. They're typically reported in liters, just because the metric system. So you go to Canada, and they're charging $1.34 Canadian per liter. Canadian dollars CAD over 1 liter. And we want to get to US dollars per gallon. So notice we have 2 different units that we want to change now. Canadian dollars and liters into something else. It doesn't really matter which one you start with. So which one would you like to get rid of first? The money or the volume? You want to be in US dollars first, or do you want to be in gallons first? Okay. So if we switch the money around here, what can we multiply this by to go from Canadian dollars to US dollars? So Canadian on bottom, US dollars there. What's the conversion that they gave you? 0.7266 US dollars for 1 Canadian? Okay. So when we do that, now we're going to be in US dollars per liter. So if you do 1.34 times 0.7266, $3.68. That's okay. I was going to say, did you do anything with liters yet, or?
I did. I calculated liters, I'm sorry.
That's okay. Yep, just one step ahead of us, I think. It's all good. Let's see. 0.9736, I think. So now we are in US dollars per liter. What can we do to get to gallons? Liter on top. And then do they give you a conversion for liters to gallons?
3.785 to 1 gallon.
Okay. So 3.785 liters. To 1 gallon. Liters cancel. And then the number you got was
3.6.
3.68. $3.68 US per gallon. Seems like more expensive gas than it is here. Any questions on how this works when you have multiple units to work with? Okay. Well, could be worse. I could have done a chemistry equation in here. What's that?
I said
No, thanks. Anyone remember good old stoichiometry? Like moles, grams, atoms. Yeah. That topic tends to fall in this type of thing too. But I think we'll save the chemistry for now. Okay. Going back to the presentation, I said the rest of the world uses the metric system. That first one is the most common conversion, and it's probably one that you should memorize just because of how frequently it shows up. 1 inch is 2.54 centimeters. That's going to be your key to go from imperial to metric or metric to imperial. So if you need to do something like feet to centimeters, or say millimeters to miles, that's going to be the key there. That'll make that happen. So if we extend unit analysis a little bit to the metric system, it was invented in France in the late 1700s. And the reason they developed it is for consistency, essentially. And everything can be done using a base 10 system. Basically, the French looked at what we had, and they were like 12 inches in a foot, 3 feet to a yard. We're going to go crazy with these different numbers. So what they did, they have prefixes already. Centi would be 100, milli would be 1,000. We have bases here like grams for mass, meters for length, liters for volume, seconds for time. They would just add the prefix in front of it, and that will tell you what order of magnitude the measurement is. Fun fact for you from physics. You know how a meter is defined? It's interesting. It's the amount of distance that light travels in a vacuum in 1 almost 300 millionth of a second. And that's based on the speed of light there. But all of these are derived from crazy scientific things like that. But regardless of how crazy they are, it's an objective standard that could be used anywhere on Earth. So they could do this in France, we could do it right here, we would get the same result. But again, prefixes for the metric system. Small values are lowercase, typically. The only interesting prefix is micro. You can see MC for micro, or you could see mu, which is that weird U looking shape that has a tail in the front of it. It's actually a Greek letter there. Large values are typically uppercase once you get past kilo. But there's actually one place where you would have seen these bigger values. Anyone in here get a new laptop recently? or within the last
RAM values.
RAM values.
Yeah.
Mm-hmm. Yep. Mhm.
Please don't remind me about RAM right now. I can't
No?
think about the prices of RAM right now.
Oh, I'm sorry.
It's so bad.
One thing you might find interesting over time, did you notice anything about the amount of RAM that laptops can hold? Like 5, 10 years ago, everything was in terms of gigabytes. A lot of the new ones now will say terabyte. Terabyte is a larger unit than gigabyte. So over time, the amount of space that laptops can hold is actually increasing. But they report that in terms of the metric system. So if you're going from a larger unit to a smaller unit, subtract the exponents and move the decimal place that number of spaces to the right. Because the metric system is based on base 10, that's why you're allowed to move the decimal. And that still works. If you're going from a smaller unit to a larger unit, same process, except how you're moving the decimal changes direction. So you'll move it to the left if you're going from smaller to larger. Oh, okay. Okay. At one point, there was a remote up here for this. Is that it? Oh, okay. I thought it might have been for something else. Okay. Any questions so far? Okay. I'll tell you what, you think good place to stop for tonight? Okay. So then what I'll do here, I'll just show you the calendar of things that are coming up. Have you ever used the calendar in Canvas? Off to the left hand side, you can go there and the calendar will show you the different things that are due for your classes. So I had all of these things set to be due tonight. Does that still work for everybody? Okay. I was going to say, I know with the first two classes being remote, if I need to move one or two of those back to say Monday next week, I'm open to that. But just kind of let me know what you need there. Monday next week, we'll have our first in-class assignment, which will be based on Chapter 3 and a little bit of Chapter 2 potentially.
There isn't anything due this weekend, is there?
Nope, just the homework assignments tonight. Yeah,
Thank God.
yeah. I try not to have things due on weekends. It'll probably be due on like class nights typically. And then the online section, same goes for you. I try to keep the calendars pretty consistent between this section and the one online. So everybody's in a similar place there. But if you have questions on anything, just feel free to send me an email at any time. Always happy to help you. Sound good? Okay. So then we'll pick up here on Monday then. And I just found out that DuBois School District is calling for a 2-hour delay tomorrow already. So,
The school around, like where I live, they did it for the rest of the week,
yeah,
just because it's been like really cold.
Quick will have absolutely nothing.
Huh?
Quick will have absolutely nothing.
I'm sure they probably will, because Phelpsburg did and DuBois did, they're right smack in between. You don't think?
No.
oh, this is a good question for me to ask. How many of you are coming from outside of DuBois? All of you.
Oh.
Okay. Where are you all coming from?
Woodland.
Okay, Woodland, Punxsy.
I'm West Decatur, yeah, like Phillipsburg, West Decatur.
West Decatur.
Yeah.
Okay, Brookville. Okay. I used to live in Clearfield for a long time, so I am familiar with that part too. It can be an interesting drive in the wintertime.
Yeah.
You could say that.
Yeah. So if there's ever a question with weather, I'll try to err on the side of caution if you're driving like that far away. So that's good for me to know.
Yeah.
Because I think 2 that I had last semester came from Phillipsburg.
Yeah.
So,
When I drive a little dinky Volkswagen Beetle, so you can't even get out of the driveway half the time, so,
oh boy.
yeah. It's not the best place I have made corners.
Yeah, I almost got stuck down at the light down here.
Oh boy.
I was like, oh no.
Alrighty.
Well, stay safe out there.
You as well.
Thanks.
Nice meeting you.
Yeah, nice meeting you.
Finally.
Yeah.
Yeah.
Yeah. Took us an extra week.
Yeah. Have a good weekend.
You too. Thank you.
You're welcome.